So this one is May 2018 exam paper, Unit 6. The first one, student has a sample of a wire and that is made from unknown metal. In order to identify the metal, she determines the resistivity. Student estimated that the diameter of a wire is approximately 0.5 millimeter. She measured a diameter of a wire using a micrometer. Explain why micrometer screw gauge is appropriate instrument for measuring a diameter. So what is the reason why the micrometer screw gauge? Because if you check the least count, the smallest value which the micrometer can record, that is 0.01 millimeter. So why micrometer is like suitable? Because it can measure 0.01 millimeter. That's a least count, or the least value which we can measure accurately by using a micrometer is 0.01. And if we want to work out the percentage uncertainty, like what will the percentage uncertainty? The percentage uncertainty is the uncertainty which is 0.01 divided by the value recorded, which is 0.5 into 100. So when we simplify, this will be 0.01 into 100, 1 divided by 0.5, so it will be 2%. So if we use a micrometer screw gauge, the percentage uncertainty will be 2%. And the smallest value, like it is within the, it's not below the smallest value which micrometer can record. And the second mark is comparing the percentage uncertainty or calculating the percentage uncertainty. Describe two techniques should be used to make this measurement as accurate as possible. So whenever we are using a micrometer, what we should do, we should always check for the zero error and repeat with different orientation and take an average. So whenever a micrometer screw gauge is used, we should always check for zero error. And we have to repeat with different orientation. So when we measure, like example, first we measure from this side, then like if we are measuring a diameter, so we place between the jaws, and first the jaws are in this orientation, then the same, we change the orientation. So whenever a micrometer screw gauge is used, we should always check for zero error and change the orientation, repeat with different orientation and take an average. That's how we can improve the experimental accuracy. She measured a diameter which is having the value of 0.275 with an uncertainty of 0.003. Calculate the percentage uncertainty. So percentage uncertainty is the uncertainty which is 0.0003 divided by value recorded, which is 0.275 into 100. So this will be 1.1%. The next student measured the length and the resistance of a wire and obtained the following results. Calculate the resistivity. So if you want to calculate the resistivity, we have the formula R is equals to rho L by A. If we need resistivity, resistivity is RA divided by L, where R is the resistance, which is 6.48. A is the area of cross section we have to work out by using a formula pi d square by 4 if we have the diameter, or we can use pi r square. That's how we get the area of cross section of wire. Diameter is given in the previous one, that is 0.275. So it will be 0.275, like pi into 0.275 divided by 4. So 3.14 into 0.275 square, and this whole is divided by 4. and then, sorry, length into area. So yeah, area is 0.27 divided square divided by 4 and divided by length. The length is equals to 0.8. So this will give us a value for resistivity of the wire, that is 4.8 into 10 to the power minus 7. And the unit of the resistivity is ohm meter. The next, calculate the percentage uncertainty in value of the resistivity. Whenever quantities are multiplied or divided, we always take their percentage uncertainty. If quantities are added, we just directly add the uncertainty, added or subtract. But if quantities are multiplied and divided, we take out the percentage uncertainty in each quantity and then we work out the total uncertainty by adding the percentage. So resistivity is equals to RA divided by L. So what we'll do, we'll find the percentage uncertainty in R, we'll find the percentage uncertainty in area, and we'll find percentage uncertainty in length. How to work out the percentage uncertainty in R? Uh, as is mentioned in the question that these values are given, like resistance is there and 0.03 uncertainty. So 0.03 is the uncertainty divided by value recorded for R, which was 6.48 times 100. So we multiply, we'll get 0.46%. Now, what about the uncertainty in area? Area we calculated by using pi r square. So, or pi d square by 4. So, and there was an uncertainty in diameter which we worked out, it was 1.1%. But because it is a power square, pi is constant, 4 is constant. So the uncertainty, the percentage uncertainty in D will be twice if you want to calculate for area, because it is pi D square by 4. So it will be 1.1 times 2. That's equal to 2.2%. And in length, the uncertainty in length, the least count is 0.001 divided by 0.8. So 0.001 divided by 0.8 into 100. This will give us the percentage uncertainty in the value for length. That is 0.13. Now to calculate the total uncertainty, percentage uncertainty 0.46 plus 2.2 plus 0.13. You just simply add them and the total uncertainty will be 2.8%. So as they ask for percentage, if they ask what is the uncertainty, then we'll find 2.8% of this value in the resistivity. Like resistivity value was 4.8 into 10 to the power minus 7. So if they are, if the question was what is the uncertainty, so we'll find 2.8% of this value to get the uncertainty. But because the question is calculate the percentage uncertainty, that's why we don't have to take 2.8% of that. Then the table lists resistivity of some of the metal. Explain which metal is most likely to be made. So when you check the resistivity, our answer was 4.8 into 10 to the power minus 7. So which one it matches with? It matches with constant 10. But you have to work out in terms of percentage difference and percentage, like it is closer to constant 10. So how you work out, you'll find the percentage difference, and if the percentage uncertainty is less than percentage, like when we work out the percentage difference, if the percentage difference is less than the percentage uncertainty, it means the values are same. So when we work out, because it's of 3 mark, 1 mark is for identifying the metal, 1 mark is for calculation. Whenever comparison is there between the two quantities, If the percentage difference is more than percentage uncertainties, two values are not same. But if the percentage difference is less than percentage uncertainty, then the two values are same. So we'll calculate the percentage difference. Percentage difference is the maximum minus minimum divided by the standard value. Like because we have the standard 4.9, so maximum minus minimum divided by standard into 100. The maximum value, that is 4.9, minimum value is 4.8 minus divided by standard, which is 4.9 into 4.9 into 10 to the power minus 7 into 100. So when we multiply them, this will give us the percentage difference 1.8%. And the percentage uncertainty, when we calculated in the previous part, it was 2.8. So percentage difference is less than the percentage uncertainty. It means the two values are equal. So we can say that this 4.8 is approximately equal to 4.9. So 1 mark is for mentioning that it is constant and 1 mark is for calculating a percentage difference. And the last one is writing a conclusion that percentage difference is less than percentage uncertainty. Is it clear, this question? In question 2, a student connect a variable frequency signal generator to oscilloscope. The oscilloscope displays the output, which vary with the time as shown. On the horizontal scale, the oscilloscope screen, one division represents 50 milliseconds. Show that the frequency. So first we'll work out the time period. Like this is one complete vibration. So there are 1, 2, and 3 boxes are there. So total time will be 150 millisecond time period, or we can say 150 to 10 to the power minus 3 second. But we need frequency. Frequency is reciprocal of the time period, so we divide. So it will be 115 to 10 to the power minus 3. That is about 6.67 hertz. The student uses a variable resistor. The student uses a variable frequency signal generator. The coil of a wire is a property known as impedance, that is V divided by I, where V is the potential and I. Z is thought to vary with the frequency to an alternating current, where L and K are constants. So this equation is a write a plan to investigate the variation to verify the relation between this Z square is equals to 4 pi square L square F square plus K square using graphical method. You said the additional component what we need, because where V is the voltage and I is the current. So what are the things we need? The additional component we need to measure this Z. We need voltmeter and we need ammeter. The measurements to be taken. So what measurements we have to take? F is a frequency. So we have to measure the voltage and the current, and we have to measure a time period, and from time period we'll work out the frequency. Like using a voltmeter, we'll get voltage, current, we'll get impedance, and then how to work out the frequency? Frequency is reciprocal of time period. So using our oscilloscope, we'll work out the time period, and time period take a reciprocal to get the frequency. Then how the measurement would be used? So how we can use these measurements? So that I just mentioned, like voltage divided by current will give us Z, and then we'll take Z square, and using the oscilloscope we'll work out time, and from time period we'll find the frequency. Then sketch expected graph. So when we compare with y is equals to mx plus c, On y-axis, if we have z square, and on x-axis, we have f square, gradient is 4 pi square L. So these are all constant. And so there will be a positive y-intercept because this is representing a y-intercept. So y-intercept, and there will be a straight line which is passing, like it's not starting from origin because there is a y-intercept. And why it is a straight line? Because 4 pi square L, these are constant. So it should be a straight line above the origin or having a positive y-intercept. Is it clear?